present here. This is Selvaprabhu from CSE department. So currently I am handling data warehousing subject. From this subject I am going to take a lecture on the second unit, which is called ETL and OLAP technology. The core objective of this subject is, the first one is to know the details about the data warehousing architecture. The second one is to understand the technology which is given by OLAP. Third one is to understand the strategy of partitioning. Fourth one is to differentiate various schema that is being used in this particular data warehousing concepts. The fifth one is to understand the roles of the process manager and the system manager. Once these objective gets success, the outcome from the student will be the following. The first outcome is they can able to design the data warehouse architecture for various problems. The second one is they can able to apply the technology which is given by the OLAP. Third one, they can able to analyze the partitioning strategy. The fourth one, critically they can able to analyze the differentiation of various schemas for the given problem that is being used in it. The last one is they can able to frame the roles of process manager and the system manager. Once these outcomes is being executed successfully, students are well versed in this particular subject. Let's move into the topics that is involved in this particular unit. The topics to be discussed here are: what is ETL, ETL versus ELT, the types of data warehouse design and modeling, delivery process, online analytical processing OLAP, characteristics of OLAP, online transaction processing OLTP versus OLAP, OLAP operations, types of OLAP, the types are ROLAP versus MOLAP versus HOLAP. Let us discuss each topic in detail. The first topic is ETL. What is ETL? ETL means extract, transform, unload. So ETL stands for extract, transform, unload. The process used in data warehouse is to extract the data from various sources, and it transforms this data into suitable form of information, and it will be loaded into the data warehouse. Once it is being loaded into the data warehouse, the process gets completed. So it is being divided into three stages. One is extract, second is transform, and third is load. So in the first stage, the ETL process extract the data from the various sources like spreadsheets, flat files, transactional systems, etc. And this data involves relieving data from source systems and sorting it in the staging area. The second stage is called transform. Here the data information is being transformed from the extraction of data, and it is being loaded into the data warehouse. It involves cleaning, validating the data, converting the data types, compiling the data from multiple sources, and creating a new data files. So the last stage is the load stage. Here the data is being transferred and it's being loaded into the data warehouse. It involves critically the physical data structure and loading the data into the data warehouses. So this is called ETL. So ETL has three stages. One is extract, one is transform, and another is load. So this is how the process is being carried out. RDBMS, SQL Server, flat files, these three things comes under extraction. When these data are being extracted from different sources, it will be extracted to the transformation stage where the staging area is being located. Once the staging area is being completed, it will be transferred to the third stage, which is called loading, where the data house is being presented. So extraction, which has been already discussed neatly there. So I have given some information about this. So let us see about transformation. So transformation is a set of rules or application that can be applied to the extracted data. So without these rules or functions, we can't able to extract the data in a single standard format. So in order to follow these rules and functions, we have some process or task. So one of the tasks is filtering. So loading only certain attributes into the data warehouse, which means you can able to load only certain attributes that is being given by the data source into the data warehouse. Second one is cleaning. So cleaning means filling up the empty values or filling up the empty space with some default values mapping. So it has USA, United States and America into USA. So which means if we have a table like USA, United States and America, it will be all converted into USA. So it fills as common data. Third one is join. So it joins multiple attributes into one category as we saw here. So USA, United States, America, everything are same. So it will be joined together as USA. The next one is splitting. So here the single attribute is being splitted into multiple attributes. That's called splitting. The last one is sorting. So sorting tuples are the basic of some attributes which is being generally created by the key attributes. This is called transformations. So last one is loading. So here the data will be loaded from the staging area towards the data warehouse area with regular intervals. So this is how each process being taken place. So n number of processes will be taking place. So each process have the three types: extract, transform and load. This is how the process is being taken place. So we have different types of tools that will be used in ETL. So here the different types of tools used in ETL are Hivo, Sybase, Oracle, Warehouse Builder, Clover ETL and MarkLogic. And we also have different types of data warehouses which are called as Snowflake, Redshift, BigQuery and Fireball. These are the tools and data warehouses that has been commonly used for these purposes. What are the advantages? If we go for the advantages that is being used in the ETL process are improved data quality, better data integration, increased data security, improved scalability, increased automation. So these five are the major important advantages that have been found. There are still more advantages available in internet. So but these five are the main important thing. So once we go for the disadvantage of ETL process, we have high cost. Second one is complexity. Third is limited flexibility. Fourth one is limited scalability. The last one is data privacy concern. So here scalability and security concern is also considered as to be disadvantages and advantages too. So the difference between ETL versus ELT. Here as we saw that ETL means extract, transform and load. But ELT means the load comes in the middle of, so which is called extract, load and transform. So it will extract the data, it will load the data into the data warehouse. After loading the data into the data warehouse, it will be transformed to the client or the tables. So it is the main concept of it. So here are some of the points given between ETL and ELTS. So this is how the difference is being framed up. So if you take ETL, the source will be as RDBMS, PASS, IoT, NoSQL, SAS, Open Data. These all sources will be extracted and stored in the staging area. Once after the staging area has been completed, it will be transforming all the information to the data warehouse. So this is called ETL. So which means extract, transform and load. When we come for ELT, which means extract, load and transform, the process is taken place in this manner. It will extract data from RDBMS, NoSQL and SAS. It will be extract the important data which is present in the source and it will be loaded into data warehouse server. After loading into the data warehouse server, the particular or necessary data will be transformed to the target tables. Whatever the information is wanted by the user will be selected and it will be given to the user in his respective table. So once the target table is completed, it will be sent to the analysis and forecasting area. This is how the process has been taken place between ETL and ELT. So next we go for types of data warehouse. Here we will be having different types. Out of this I have given here 7 different types of data warehouse. One is enterprise data warehouse. Second is operational data store. Third is data mart. Fourth is virtual data warehouse. Fifth is federated data warehouse. Sixth is analytical data store. Seventh is real-time data warehouse. So let us go in deep one by one. So what these data types are these data warehouse do. First one is enterprise data warehouse. So it is also called as EDW, enterprise data warehouse. It serves as a central repository that integrates data from various sources. So mainly it acts as a central repository. This repository gets data from various sources across the entire organization. Example, we are running a college. So college has a central repository which is also called as library. So the library contains several sources of books. So it might be of CSE department or EEE department or EC department or AADS department. These are different types of sources available inside the organization. All these sources are collected together and placed into a central repository which is called as central library. So this is called enterprise data warehouse. If we come for the second thing, ODS, it acts as an intermediate layer between the transactional system and data warehouse. So once it acts as the intermediate layer between the transactional systems, the data warehouse focuses on supporting operational reporting and real-time decision making. So the real-time decision making along with the operational reporting can be focused still more clear so that everything takes place within the data store, operational data store. So once it comes to the next thing, third type, data mart. Sorry. So once we come to the third type of data warehouse, which is called as data mart. So data mart is a subset of a data warehouse. So generally it is also called as a data warehouse, but as a definition it is called as a subset of a data warehouse. So the caters to be needs of specific departments. Here the caters means identifying the specific needs. So identifying the specific needs of specific departments, user groups or any business functions within the organization is called data mart. So collecting the information of each and every department separately is called as a data mart. It is called as a subset of a data warehouse. As I said in the first point, ADS books, CSE books, EC books, EEE books will be segregated separately in their racks. This is called data mart. Combination of several data mart is called as data warehouse. So if we come for the fourth one, virtual data warehouse, here the concept where data is not physically stored in the central repository. So the data will not be stored in the central repository. Instead, it leverages virtual techniques to provide a logical view of data. So we can able to provide a logical view of data from various sources that is being available. So this creates the virtual data warehouse. Once we come to the fifth type, which is called as federated data warehouse, a distributed architecture that combines data from multiple data sources. So the architecture is being distributed here. It combines data from multiple independent data sources without physically connecting to the data. So the data will not be connected physically, but the sources can be taken from the multiple sources and it will be distributed to the architecture. The sixth one is ADS. It focuses on supporting advanced analytics, data mining, complex analytics queries, etc. So the last one is RTDW, which is called as real-time data warehouse. It is a design to capture the process and analysis data in a real time or with a minimal latency. So it captures the process which takes place in the real time or with a minimum latency thing. These are the 7 types of data warehouse which is involved in the process. So next we are moving to data warehouse design and modeling. So what is mean by data warehouse design and modeling means a process of structuring and organizing data in a way that enables efficient querying, analyzing and reporting. So whatever the data is being organized and structured, it should be efficient query, analyzed and reported. So if these three things enables a good thing, so it is called as a structured and organized data. So it should be efficiently querying, analyzed and reported. So some important aspect of data warehouse which is being followed here are identifying the business requirement. So without identifying the requirement of a business, we can't able to do anything. So second one, data modeling. It should be modeled. The content what we have or what we search should be modeled. Third one, ETL. So the same as extract, transform and load. Fourth one is dimensional modeling. Fifth one is physical design. Sixth one is data security. Seventh one is data governance. Eighth one is scalability and performance. Ninth one is metadata management. 10th one is user interface and reporting. 11th one is interactive development. So we have all these 11 important aspects of a data warehouse design. Without these 11 important aspects, we can't able to design a data warehouse. So all these 11 points will help in designing a data warehouse perfectly. So next we will be going for approaches. Approaches present or available in data warehouse design are, we have two approaches. One is top-down approach. It is described as a subject-oriented, time-variant, non-volatile and integrated repository for the entire enterprise data from different sources which are validated, reformatted and saved in a normalized database as the data warehouse. So it can occupy up to 3 normalization form. So 3 enough you can able to occupy. So this is called top-down approach. The second type is bottom-up approach. Here it is described as a copy of a transaction data, specifically architecture for query and analysis. So it is been architectured for basically for query and analysis part alone. So which involves star schema. Okay. So how the data, how the top-down approach is being structured is given in a format like this. So we have n number of source system. So it is being connected along with the ETL. The ETL is being connected with the EDW, which is the first data type, which is a normalized one. So enterprise data warehouse, and it is being again connected with the ETL. So this ETL, the second ETL is being connected to several number of data mart DM. The third type present in the data warehouse is data mart. This data mart follows the star schema. So this since it is follows the star schema, the data which is present from the different sources can be taken from different data mart. So example, data 1, data 2, data mart M is having different data. By using the star schema, we can able to retrieve data even though if one data mart is not having a proper connection. This is called top-down approach. The steps which are involved in top-down approaches are defining the business requirement. So we need to define how the business requirement should be there. Second one, identifying the subject area. Third one, to create a conceptual model. Fourth one, to define what is data mart. Fifth one, design the dimensional model. Sixth one, to determine the integration strategy. Seventh one is to develop the physical design. Eighth one is to implement the data warehouse. Ninth one is to enable user access and reporting. 10th one is iterate and refine. These are the 10 steps that has to be involved in creating a top-down approach. Without these 10 approaches, we can't able to, without these 10 steps, we can't able to develop a top-down approach. So all these 10 steps will be having major priority in developing the top-down approach. So next we will be moving for the second approach, which is called as bottom-up approach. So the design is being created like this. You can able to identify the difference between the top-down approach and bottom-up approach. In top-down approach, the ETL has been shown in two methods, has been shown in two times. In between there would have been enterprise data warehouse, EDW, which is a normalized one. But in bottom-up approach, we can't able to see the enterprise data warehouse and extract data of ETL process. So here we have n number of source system. It has been connected to the first one and only ETL, and that ETL is being connected with different data mart, and these data mart is being connected with connected in a bus connection mode, which is called as data warehouse bus conformed dimensions and conformed facts. These data warehouse bus conformed dimension and conformed facts will be sending the informations to the data mart in an equal manner, and from data mart the information will be extracted from the ETL and various source system. This is called bottom up approach. Here too we have the steps that to be involved in bottom approach. So identifying the data source is the first step involved in the approach. Second one is to select the pilot project. Third one is to extract the data. Fourth one is to transform and cleanse the data. Fifth one is to load data into a staging area. Sixth one is to design and create a dimensional model. Seventh one is to load data into the data warehouse. Eighth one is to enable the user access and reporting thing. Ninth one and 10th one is incremental expansion, iterate and refine. These are the 10 steps involved in bottom-up approach. The steps which are involved in top-down approach is different from bottom-up approach. Next we will be seeing top-down design approach versus bottom-up design approach. There are some of the key points given as a difference, which has been already discussed. Few points have been already discussed and few points are given here, which is example centralized rules and control. Here department rules and control. It includes redundant information. Redundancy can be removed. Departmental information stored in bottom-up approach. Here single or central storage of information about the content. So these are the different points that can be differentiate these two approaches. So what is data warehouse modeling? So it involves designing the structure and organization of a data within the data warehouse to support the efficient query, analyzing and report. So as we mentioned before itself, with the support of query, analysis and report, a structured organization is being designed. So this is called data warehousing modeling. So there are two common approaches created here too. So one is dimensional modeling, second is entity relationship modeling. So the entity relationship modeling is commonly known as ER modeling. So let us discuss in detail about dimensional modeling. So dimensional modeling, it is a technique that organizes data into star schema or snowflake schema. So the dimensional modeling follows star schema or snowflake schema, which contains the central fact table surrounded by the dimension table. So the information are retrieved from the central repository and it is being given to the surrounding dimensional tables. So with the help of star schema or the snowflake schema. So here the approach is being optimized for query performance and analytical processing. The key elements of dimensional modeling are fact tables. So without fact tables we can't able to get the data. Without dimension table we can't able to map the information with the arrived data and the hierarchies. These are the three key elements of the dimension modeling. So next, the second modeling is entity relationship modeling, so which is also called as ER modeling. So it is a common technique that is used in traditional data design and it can also be applied to data warehousing modeling. So it is a common traditional designing technique. It focuses on capturing the relationship between the entities and the attributes. So the entities and the attributes, both the things are being focused, especially the attributes which are associated with the entities. So just like that it can not be focused, the attribute should be focused or associated with the given entities. So it takes these relationship between and it gets focuses by these two. So here also we have the key elements for the ER modeling. The first one is entities, second one is relationships, third one is the attributes, and the fourth one is the primary key and the foreign key. So with the help of primary and foreign key, we can able to map that table, two different tables on n number of multiple tables with the same data which is available in different tables. So with the help of primary key and foreign key, we can able to map the data. So what is data modeling life cycle? The next topic is data modeling life cycle. It just forward the process of transforming the business requirement to fulfill the goals for storing, maintaining, accessing the data within the IT system. So it actually fulfills the goals like storing, maintaining and accessing data within the IT system. The output will be as a logical and physical data model for an EDW. So it is one of the type of data warehouse, enterprise data warehouse. So the output will be supporting logical and physical data model, which is an enterprise data warehouse. The object of the data modeling lifecycle is primarily the creation of a storage area. So main thing is to create a storage area. That is the main objective of the data modeling lifecycle. So to create a storage area for the business purpose information. So once the area comes from logical and physical data modeling, it can be explained by the given diagram. So the business requirement, we are getting the requirements from the business. Once the requirement is being obtained, it is being converting into logical data modeling. Once the logical data modeling is being framed, it is being given to the physical data modeling. Once the physical data modeling is framed based on the logical data modeling, it will be given out as a fulfilled business requirement for the data storage. So at last we will be getting what to do and how to do, when to do, and these kinds of data will be fulfilled by the business requirement for the storage, data storage, and this is called as data modeling life cycle. So we have following stages for the data life cycle. One is requirement gathering, second is conceptual data modeling, third is logical data modeling, fourth is physical data modeling, fifth is database implementation, sixth is data integration and ETL, seventh is data quality assurance, eighth is maintenance and evaluation, ninth is metadata management, 10th is collaboration and documentation, and these are the life cycle which contains the stages. So with all these 10 stages, you can able to construct a data modeling life cycle. Okay. So based on these sessions, so I have framed few quizzes with optional like MCQ questions. We have to choose one of the best answer from the given option, and then the correct answer will be given once after the students have been taken place. So it has been created in a MCQ manner. So if you want, we can able to give it in a Google form manner too. So here the quiz starts. The first question states about the process of ETL can be broken into how many stages. The option are 2, 3 and 4. So generally ETL means extract, transform and load. So it is 3 stages. So the correct answer is 3. So the correct answer is given after discussing with the students. The second one is creating the physical data structure and loading the data into the warehouse is called as. So it is in the definition manner. So here the 3 options or 4 options are given. The first one is transform, second one is extract, third one is load, fourth one is none of the above. So none of the above means the given 3 options are not correct like that. So the correct answer is, it is load. The third option is the correct answer. So load is called as creating the physical data structure and loading the data into the data warehouse. So next is the third question. So it has few options, and from those options the answer will be given after that discussion with the students. Likewise this fourth question will be there. These all the questions have been taught in the class in this PPT itself. So I have created 10 objective types questions which with all options and answered with the correct answer at the end. So these are the questions. So by doing this, the students can able to recall what has been taken place in the class daily. So it can be given daily manner or weekly manner. So it is better to give in a daily manner. So thank you. If there is any question, you can ask. Thank you.